Alright, in this unit we're going to talk about rational exponents, and in each rational exponent the way that works is, if you notice up here, the index is the denominator of the fraction, right there, and the power that's either underneath the radical or outside the parentheses is the numerator of the fraction of the rational exponent. So hopefully that can help you see where these things go. Now if you look at this first example, and the instructions are simply to rewrite the expression. You're not doing any calculating, you're just rewriting. 8, the understood index here is 2, if it's the square root of 8. And the power on 8 would be 8 to the first. Even though it's not written there, we know that that's 8 to the first. So this would be rewritten as 8 to the 1/2 power when you rewrite it with a rational exponent. Okay. Now for the next example, we have our base, which is 5. The power is 8, and the index is 3, so that's going to be 5 to the 8/3 power. In example 3, all of this, 3x, all of that is under the radical, which is a little different than what you're used to seeing in the first two problems. Now there's more under the radical than just one number. It's a 3x. Well, all of that needs to be put in parentheses because it's everything that's under the radical that's raised to that power. And so it's raised to the power of 3, and the index on that problem is 4. So that'd be 3x to the 3/4 power. That's how you make rational or fractional exponents given radicals as your original problem. Now moving up, we're going to go the other way. We're going to start with fractional exponents and use radical notation. So now we want to use radical notation to rewrite each expression. Again, we're not really doing calculations, we're just rewriting expressions. So, write your base with your root. I usually do this with parentheses. That's to the first, so we don't have to write it. And the index is 5. Okay, the next one, you have 16. Whoops, go back. That's the 5th root of 16, the cube root of 16. Again, the denominator is what you use for the index. Put parentheses around the whole thing, and that's raised to the 5th power. Now, it's especially important when you have parentheses like this. This one you could just as easily write as the cube root of 16 to the 5th, and that would also be correct. But with this one with the parentheses, it's really important that you write it like I've written the examples in 4 and 5. So you're going to have 5xy squared. Put all of that in parentheses, or we're going to put all of that under the radical, excuse me. Okay. We're going to put 5xy squared under the radical, and the root, or the index, is 4. Put parentheses around that whole thing, and it's raised to the 3rd power. Okay, so that is rewriting expressions that you've gotten as radicals as fractional exponents as radicals. Now this says evaluate without using a calculator, and I know everybody tends to panic when we take a calculator away. But these are all designed to be fairly easy problems. And again, if you've learned some of these low powers, then it's not going to be that difficult. What this is saying, remember the root is what's in the denominator, so that's saying the square root of 4 cubed. Well, the square root of 4 is 2 cubed, and 2 times 2 times 2, or 2 cubed, and you need to start being able to just recognize that that is 8. Now, negative exponents. Remember, that puts it in the denominator. It doesn't make the answer negative. That makes it 1 over 9 to the positive 1/2 power, which is 1/2 is a square root, so it's 1 over the square root of 9, which is 1/3. 8 to the 2/3 power, we have the cube root of 8, and all of that squared. The cube root of 8 is 2. Let me write it this way just so you can see it. That's the cube root of 2 cubed squared. And remember, when the exponent and the, right here, when the index and the exponent match, the 2 comes out as the root. So that was 2 squared, which then is 4. Okay. Now 32 to the negative 3/5. That's 1 over 32 to the positive 3/5. Okay. And then again, that's 1 over the 5th root of 32 cubed. Now, if you remember that 2 to the 5th is 32, that's 1 over the 5th root of 2 to the 5th cubed. This index and power match, so the answer to that then is 2, 1 over 2 cubed, which, I'm going to go up here, is 8. 1/8, excuse me. 1/8. Okay? All right, so now let's move on to our next page. Here we're using the laws of exponents. We learned these laws of exponents back in Chapter 8. Now we're just using them with rational exponents, but the rules still stay the same. We're multiplying bases with exponents, so we add the exponents. That makes this 5 to the 3/4 plus 1/4. Okay, which then is 5 to the 4/4. 4/4 is 1, so that's 5 to the 1st, or just 5. All right. A to the 1/2, you have parentheses raised to a power, that means you multiply. So 1/2 times 6 is 6/2. And B, 6 times 2 is 12, so that's 12/3. Then we're going to reduce those fractions, and so that's A cubed B to the 4th would be your final answer on that problem. Again, parentheses raised to a power, you multiply, but what you have to remember is this also has to be raised to that power. So you have 27 to the 1/3 power, C to the 6/3 power, and D to the negative 3/3. Okay? This means the cube root of 27, which is 3, C squared, and that's negative 3/3 is the same as negative 1, that should have been a D. So all of this is over D to the 1st, and that's your final answer. Okay. Everything in here is raised to the 2/3 power, so this becomes 8 to the 2/3 times A to the 24/3 over 27 to the 2/3 power times B to the 18/3 power. Cube root of 8, that's the same as the cube root of 8 squared. Cube root of 8 is 2. So let's just go over here on the side and kind of evaluate this one. Look over here. That means the cube root of 8, which is 2 cubed, all of that squared. All of this is going to be 2, so the answer to that is 4. Evaluate this one. Cube root of 27 squared That's the same as 27 is the same as 3 cubed. So all of this has a value of 3, and 3 squared is 9. So the numbers come out to be 4/9. Then we're going to reduce fractions. A to the 24th is A to the 8th, and B to the 18 divided by 3 will be B to the 6th. Again, we're using exponent rules that we learned last unit. Okay, looking at 15, this is a multiplication problem. There's no parentheses raised to powers, so we're multiplying straight across. 5 times 2 is 10. Then we're going to add exponents, x to the negative 2/3 plus 1/3 times y to the 2/3 minus 1/3 or plus negative 1/3. Then we have 10x to the negative 1/3 y to the positive 1/3. And then we want to write those without any negative exponents. So the 10 and the y are going to be in the numerator over x to the 1/3. Okay. 16 is another multiplication problem. You have x to the negative 1/5 plus 2/5 plus negative 3/5. Then you add all of those fractions up, which some of you don't like fractions, but this is going to be negative 1 plus 2 is going to be positive 1/5 plus negative 3/5 is the whole thing's going to add to be negative 2/5. And again, we're going to write that in the denominator where it's supposed to be. That's 1 over x to the positive 2/5. And our last problem is a division. You can do this a couple ways. But let's just do it kind of how we've done it before. First, let's reduce our fraction. Look at the numbers. Negative 3/6 is going to simplify to be negative 1/2. Then we subtract, when we divide bases with exponents, we subtract them. So we have 8/7 minus 2/7, which is equal to 5/7. Okay? And where is that going to go? It's going on the side with the larger exponent, which is going to be down here in the denominator. So our a to the 5/7 is down in the denominator. And so that would be our final answer on that one.